So just to talk about some of the background projects over those last 7 years or so we've been in Canada. And I'll start pretty much with the city of Barrie because they're a good example of how we've worked with cities and municipalities across Canada. Um, Initially, we started with one pilot LittaTrap, which we put in the council operations yard, and they put it in a washdown area, and the one unit got completely hammered with material that was being washed out of garbage trucks and garbage bins, and it had to be emptied twice every 2 weeks because there was just so much material. But that was a real good test on the technology, and the municipality we got really comfortable with maintaining it because they were maintaining it a lot, and then they thought, oh, this is easy to use. We like this. Let's have a look downtown and let's see what how much trash and debris are coming off the city streets downtown. So they removed that one unit they had in the operations yard, and they put it downtown on the waterfront, and they're really amazed about how many materials. I think they caught about 800 pieces of litter in a summer period. And that really made them think, well, we have quite a serious problem here of amount of trash and plastic and litter washing off our city street. So then they stepped it up and they've now rolled it out to over 100 units through the downtown area of Barrie. And Barrie are now maintaining them on a 6 monthly basis. They're finding them very easy to maintain, as I said, and happy to be an endorsement to anyone who wants to talk to the City of Barrie about their LittaTrap experience. Another project, one of the many projects we've done in Ontario, is our work that I'm very proud of, is our work with the University of Toronto trash team and the Canadian plastics industry. I don't know if you're aware of what a nurdle is. Well, a nurdle is a pre-production plastic pellet. It's the precursor to making any plastic product. They get these small plastic pellets which are typically 1 millimeter in size and have a specific gravity of about 1, so they're neutrally buoyant, and they melt them down to make plastic products. Now, the plastics industry worldwide are quite concerned because these plastic pellets can be found on every beach in the world. If you go to any beach in the world and you look into the sand, you'll find these little plastic pellets. And it is a major problem. And some companies are getting huge fines and lawsuits brought against them for not controlling these plastic pellets. And they're actually very hard to manage, actually. They seem to have a mind of their own. If you spill them, when you try to sweep them, they just run off because they're very low density and very small. So we worked with the plastics industry to see what we could do and how we could address this. And there's this program, a global initiative called Operation Clean Sweep. And that's where the plastic industry is trying to regulate themselves and get plastics factories to address this issue. And their goal is zero pellet loss, which is quite challenging. 100% capture of anything is very challenging. So we worked with the University of Toronto and the plastics industry, and we went to one of these Operation Clean Sweep sites. And this site was actually a really good site. It was a very clean site where they had really good management procedures in place to stop these plastic pellets being lost. But as I said, they're very difficult to manage. And so we put 5 LittaTraps and monitored over the course of a year and got over 50,000 pellets captured. In the LittaTrap system, we can remove the overflow or the bypass of the system. And we removed them from these LittaTraps because we wanted to have 100% capture. And again, very easy to maintain. They found it relatively easy. And this was a real eye-opener for both the plastics industry and the University of Toronto. And this project has now progressed to a second phase, which is happening this summer, where we've got 7 different factories, and we're working with the Ministry of the Environment, Ontario, as well, to see how much of an impact it can have downstream on Mimico Creek. So we're actually monitoring what we're capturing in these 7 factories and at the outfall immediately downstream of that. So that's going to be a really good study to see if we really can eliminate this problem of plastic pellets. So that's a bit of background on LittaTrap and some of the work we've done in Ontario, Canada. We have got a few other installations in Alberta and British Columbia and out in the Newfoundland as well. But mainly we've been focused in Ontario. And as I said, there was a requirement and with many municipalities to remove suspended solids. So we adapted the LittaTrap and we created the EnviroBasin. So the EnviroBasin, we're terming it as an at-source sediment and trash capture device. And that's different to source control. You're probably all familiar with source control. We're terming this at source. So we locate EnviroBasins at the source of the pollutants. And that gives a lot of advantage and a lot of cost savings in implementing stormwater management or pre-treatment to other green infrastructure or green infrastructure devices or low impact devices. As I said, it incorporates the LittaTrap, which was approved. It was certified by the California Water Board at 100% trash capture. But we also can achieve over 60% suspended solids removal according to the Canadian ETV oil and grit separator protocol, or the ISO 14000 approval verification scheme. It is an alternative to both a normal catch basin because it conveys water from the hard stand area into the stormwater network, but it also is an alternative to an oil and grit separator, treating the water at the catch basin. So just going through the components, I hope you can see the video on the right. Obviously, it's pre-manufactured and pre-installed. Now, we do this because there's a lot of cost savings in pre-installing it. I'll just go through these parts. It has a submerged outlet or the pod box baffle box. This is the support frame of the LittaTrap, the filter box being installed, and the adjustable seals. The seals are put in there, and then goes the LittaTrap going in the bottom, the normal LittaTrap bag, and there's an additional flow modifying component called the deflector dish. Now that goes into the bottom of the LittaTrap bag and sits there. So it's got a few extra components, and as I said, it's pre-installed in the catch basin, and we do this because you don't. What we find is a way a catch basin insert is dependent on the structure it is put into. The catch basin is put into the depth, the size, the geometry of the catch basin influences how flows through the device. So in order to make it consistent and repeatable performance, we've pre-installed it in that concrete structure. It also has a lot of cost savings too, because you don't have to go out and clean the catch basin out at the end of the construction season and then try to put the components in. There's confined space is managed in our factory and our warehouse, not on site where you need traffic control and other extra costs. And also what we find is while catch basins look very simple to install, many contractors really struggle to install them all in line. They have to be brought up to grade of the road, and often the curb and the road and the catch basin are all not aligned, and it often is very difficult to put the components into a catch basin in the field. We can do that, but it requires just this extra work. We need to do an assessment. We look at the catch basin first. We ensure the dimensions are right, and then we go to install it, as I said, with confined space and traffic control. So it is possible to retrofit the technology, but it is preferable to just put a pre-installed and pre-manufactured system into the ground. One other advantage with it, by pre-installing it, is that you can put a geotextile liner in the LittaTrap basket to prevent sediment during that construction phase. So you're getting a sediment construction management, sediment control device, as well as a permanent stormwater treatment device as well. So just running through those components again. Let's turn on the laser pointer. The outlet baffle, the LittaTrap basket and componentry, and the energy deflector there. So, and here's a picture of one at our precast yard in Ontario. It's adjustable in height. It has a riser block here, because sometimes when we're discharging into green infrastructure or LID systems, tree planter boxes, the outlet needs to be higher. And it comes, as I said, completely together with the grating frame on top. We also have maximized the sump storage. We've extended the sump so we can get longer maintenance frequencies before you have to maintain the system. It has a range of configurations as well, and pretty much we can work with any sort of existing precast structure or at source catch basin or inlet sort of structure. But we have a twin design as well, which would use 2 LittaTraps and with 1 outlet. We have a manhole system as well, which is adaptable to round manholes, and we also have a curb entry that doesn't have a grate, which is a curb entry system is also really useful for maintenance purposes because the whole system is located in the footpath, and so it can be maintained without the worry of parked cars as well. So the water would enter the curb entry here and here. And we're using the standard catch basin design that you'd see in places like London or Peel, the region of Peel. They use the curb entry design. So to show you how it works, oops, let me just move this. So the picture on the left, that's a normal catch basin. So water in a normal catch basin is taken from the hard stand area and diverted into the catch basin, where it drops below the grate and into the sump. And you can see a huge amount of turbulence here of the water that's in the sump. Now, any catch basins can capture sediment if you have to clean them out periodically anyway. But what you'll find is that they only can really build up 100 or 150 mils of sediment before this turbulence will start resuspending any captured sediment. Now, when we put an EnviroBasin in, what happens is the water falls down through, diverted into the LittaTrap basket, and then the energy deflector at the bottom of the LittaTrap basket actually reverses the flow and pushes out to the side. And you can see quite clearly here there's a huge reduction of turbulence in the sump of the catch basin, and that's the magic. That's how we remove sediment and also retain sediment in much higher flows. And this is what we observed during our testing in Mississauga, and we decided to take this forward into the EnviroBasin. As I said, we first tested it for trash capture, and during our testing, and we needed to do this to get certified by the the Californian Water Board. And so we tested the system up to 15 litres a second. And we used a mixture of trash and debris, which is from the Caltrans testing protocol for trash devices. And the trash that you test is almost, it's like long sheets of plastic, foam bubbles, cigarette butts, also pieces of paper and pieces of cloth. And the mix that you use is really designed to kind of blind and stick to a screen. You know, it's actually similar to, they based the mixture on what they were finding in trash capture devices. So they load up the screen just to see how well it can perform and how much flow it can pass before it would blind and cause resuspension. So we caught, as I said, 100% up to 15 litres a second. And very rarely, you know, you see more than 15 litres a second going into a standard catch basin in Ontario or Canada. You know, typically the maximum design flow for a catch basin is around 20 litres a second in a 1 in 10 year storm. So that's really capturing 100% of trash up to about a 1 in 6 or 1 in 8 years design storm. The big thing about it too is this trash mixture, not all of it floated on the top of the water. Some of it floats actually in the water column. And plastic is typically has a specific gravity of around 1. So that means it doesn't necessarily rise or sink, it actually floats in the water column. And the only way you can actually really capture 100% of that is by physically screening it. As I said, we took this data forward and added some hydraulic testing. We've tested the system and the screens to really understand what flow rates it works at different levels of full. actually in the testing at 15 litres a second, this is the picture here, it was around, we estimate around 85% full, and it was still conveying 15 litres a second. We also include the type of materials it's used and how to operate it, maintenance manuals, and also warranties. And the system comes, the LittaTrap actually comes, the componentry comes with an 8-year warranty. It's made out of plastic, but it's made out of not single-use plastic and industrial plastics that are designed to last forever. That's probably the reason we have a problem with the marine plastic in the world. Some of these plastics don't break down at all. And I mentioned neutrally buoyant. Well, this is what I mean by neutrally buoyant. This is a diver in Bali. He's having a great time, except for all the plastic that he's seeing. And this plastic is neutrally buoyant. You can see it suspended in the water column. And the only way you can get this out, as I said, is by screening. You can't get it by conventional separation that you, majority of the oil and grip separators verified under the ETV do. You need a screen. And there's only one other ETV verified product that screens trash as well as captures sediment. So as I said, we were verified, and you can go to the Canadian ETV website and download the verification report. It's tested, and it has all the performance as well as the operational aspects. It was tested, as I said, in Mississauga, and we followed the oil and grit protocol, with the one exception. Then rather than bringing the water into the device with a pipe, we brought it in on a streetscape. Here is the artificial streetscape, and water would flow down the streetscape, and we would add the test sediment, and then it would fall into the catch basin and come and go through the EnviroBasin here. Well, then the EnviroBasin here is made out of plywood. It's the same dimensions as a standard EnviroBasin, but during the test protocol, you have to run the test for a certain amount of time and then take the system apart and remove every bit of sediment you've caught and dry it and weigh it. So we needed to be able to take the EnviroBasin apart. So if we made it in a precast concrete structure, we wouldn't have been able to take it apart. It would have been very difficult to do the test. The particle, the material that you test for the sediment is actually very, very fine. It's a defined particle size distribution that is the same as the New Jersey particle size distribution, if we have anybody south of the border tuning in, and also the Canadian ETV protocol uses the same particle size. That sediment has 100% less than 1 millimeter in size, with a D50 of 75 micron. So that's the 50% of the particles are less than 75 micron. And it's really important that we test fine sediment. We don't use coarser sediment, because the finer sediment has a greater affinity to other contaminants such as heavy metals and nutrients. So we really want to test a particle size that's representative of actually what we see in stormwater, and that's what the Canadian ETV does. It is what we're seeing in stormwater, the particles, the size of the particles. So here's the results, and we have a rating curve in the Canadian ETV protocol. You don't necessarily test to a flow rate. You test to a surface loading rate. Now, the surface loading rate is the surface area of the sump, or the water volume, the storage volume in the bottom of the device. And then it's the flow rate over that. And this allows you to be able to scale the technology to different sized devices. So we test to a surface loading rate rather than a flow rate. And you can see at the lower flow rates, we're above 60% removal rate. And as it moves out to higher flow rates, it drops off. To give you a perspective of what this is, a flow rate here at 200 liters per minute squared is approximately 1.2 liters a second. So in the lower flow rates, we're well above 50 liters a second, but in the higher flow rates, it drops off. Now, if you look at this and you compare it with maybe a standard oil and grit separator, you'll find maybe their results are slightly higher than the EnviroBasin. However, they are typically located downstream, inline or at the end of a catchment. So they are managing much higher flows, and typically they operate in an area more around here. And as far as liters per second or a surface loading rate, where the EnviroBasin, because it's located at the source, actually has a lot lower flows coming to it. And so we typically operate in an area around here over a year. If you took at all the rainstorm events over a year, we're typically, the flows coming to the device are generally below 1 litre a second. And that enables us to get over 50% removal from the device. Another thing that we have to test when we're doing the Canadian ETV testing protocol is the resuspension testing. And this is critical because it's not very useful if a device captures a lot of sediment and when it rains hard, it just throws it all out. Some operations people might like it because it would be self-cleaning, but it's not really that good on the environment. So the resuspension test is a critical part of the ETV process. And how they do this is that you fill the sump up, or the storage area up for the sediment, up to 50% of its capacity. And then you start lifting the flows up. As I said, start at 1.2 litres a second, and then you move up to over 15 litres a second. Now, in order for it to qualify and meet the performance standard, you need an average sediment effluent concentration of 20 milligrams per litre. And as you can see, we're pretty much below 3 milligrams per litre all the way through. Here. And that's, in my mind, elimination. I didn't know what elimination was before COVID, but that means pretty much everything, but not everything. And so we eliminate resuspension from the system. So this means, well, in low flows, we're getting over 50, 60% removal. In higher flows, we're not losing anything. So we can capture sediment in those lower flows, as well as all the trash, and retain it in even the largest storm event. And as I said, 15 litres a second is probably a 1 in 7 or 1 in 8 year storm. So we can maintain it right through your large summer storms. So what this means is you can put a whole bunch of catch basins in on your site and then add an oil and grit separator, or you can just put EnviroBasin in and not need that downstream infrastructure. So that will save you on one, just supply the purchase of an oil and grit separator, the installation of the oil and grit separator, and a lot of pipe work, because quite often that you need to collect all the catch basins together. You need to take it to the oil and grit separator to be treated, and then you need to put it back to where you're going to discharge. Often oil and grit separators have to be placed offline. So you need to put things in a bypass situation as well to handle those peak design flows. And that all adds up to a lot of extra stormwater infrastructure that's really not required if you treat at source. Another really important thing and an advantage over conventional separators is the hydraulics and driving head. So every separator or every treatment device requires a driving head to make it work. In an oil and grit separator, water typically spins in a vortex. And in order to make it spin in a vortex, it builds up driving head. And here's the driving head on a schematic of what an oil and grit separator. And see, that's creating a tailwater in the inlet pipe. Now, in Ontario, it's very flat. And we also have a lot of issues with rising lake level rises in the summer as well. And that also creates a tailwater as well. These can combine to really reduce the capacity through the treatment device, which can cause flooding upstream because it just backs all the way up. So often it's very difficult to make these systems work when you have very large flat pipes as well. Plus also when you have large flat pipes, you get a lot of deposition of sediment in these pipes, which then also reduces the capacity of it. The EnviroBasin incorporates all the driving head in the system. You have, as the water drops from the road level to the outlet pipe, That's roughly around about 600 mils to a meter, and that provides all the driving head to make the mechanism work. Uh, um, we've also incorporated a bypass with 88 litres that has a capacity of 88 litres a second. And that's, as I said, well above the 10-year storm. So, and actually more than what you physically can get inside the grate. There's a safety factor applied when we're applying what can get through the grate because of leaves that can build up and fall, etc. But we've ensured that the EnviroBasin has a bypass through it much greater than your design storm. As I said, the whole thing also was very shallow. When you look at large separators, they can get up to 3, 4, 5, 6 meters in diameter. I don't know what that is, Will, in feet, but 18 feet in diameter, 20 foot in diameter. And they also can be 20 foot deep. And that can often be a real challenge with high groundwater level. And that is also an issue in some parts of Canada as well. The EnviroBasin is only 1.5 deep. So that means it can pretty much be fit in anywhere with hydraulic or high water level area issues or challenges. So we did the testing with the ETV, but that's good. That shows it works. But how do you actually apply that as a designer, as a stormwater engineer, looking to size these things for your project? And so we worked with AECOM, a London office. We did the testing during COVID, and I couldn't get up to observe. So we worked with Bill Trenuth from the AECOM in London, and he supervised the testing. So we actually applied an extra peer review on the testing that we did. And they watched all the testing and they verified all the results for us. And then they also developed a sizing tool for us that uses historical rainfall through the Greater Toronto area to determine what the long-term suspended solids removal efficiency would be. And we offer a free service to people. You could come to us and give us your catchment areas, and we will work out where you are and calculate what your efficiency will be. And we can also work with you on how to maximize that efficiency. We can push it from 50 to 60%, or if it's, say, pre-treatment, 40% may be all that's required. So how does this sizing tool works? Well, we have a number of rain gauges or data from rain gauges across the GTA here. And we've got the historical rainfall from between 15 and 25 years for each of these rain gauges. We also can use a design storm as well, an SCS 6-hour storm, and we can modify the sizing tool to any design requirements you have. So we have historical rainfall, and this is a 10-minute time step, and this is millimeters of rainfall depth. And you can see here that there's some peaks here up to, say, 12 millimeters in a 10-minute period. But the majority of these rainfall events is under 2 millimeters. And under 2 millimeters, by chance, is 1 litre a second. So this is what I was mentioning before. Most of the flow that will come into an EnviroBasin is under 1 litre a second. And then we determine the catchment area. Here's an example of what maybe the catchment area is, and say that's 500 square meters. And we do a simple rational calculation. We take 500 square meters. Each time step we determine what the flow rate would be at that time step with that rainfall and depth intensity over 10 minutes. And then we determine the percentage removal. And we add up each time step, ding, 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 across the whole 15-year historical rainfall data. And we sum that all up to get a percentage removal. Obviously, we can adjust the catchment area if it's a new site, or if it's a retrofit, we can determine what sort of efficiency you're likely to get for that location. As I said, free design service, free sizing, and we'll give you a nice little report on what we can do so you can give to your regulator. This is what the efficiency through the device is. So the system is easily maintained, but it actually is a little bit different to a conventional oil and grit separator again, because we're catching trash and debris and plastics as well. So it has two phases. There's the LittaTrap maintenance, which is the basket, and this can be maintained by hand. It doesn't need a expensive Vector truck. Two people in a pickup truck can go and pick this up, and when you look at the cost of two people in a pickup truck versus the cost of a Vector truck, they're roughly the same. It's $500 an hour for a Vector truck, and it's $500 a day for two people in a pickup truck. So you can get around and do the periodic maintenance of the LittaTrap basket quite easily at very low cost. And so this only needs to be done between, well, we say 3 to 6 months, but the work we've been doing with Richmond Hill, they're delighted to say that their LittaTraps are lasting annually before they have to maintain them. And that's in quite a leafy area. What happens is we see all the leaves compress down and almost compost inside the system, just definitely compressed down. And so that keeps the capacity of the LittaTrap basket large. There's roughly 40 litres of storage capacity in the LittaTrap basket. So that can take quite a bit of trash, debris and compressed leaves. So we say 3 to 6 months, and typically twice a year is probably a better thing to say. And we definitely recommend at the start of fall and at the end of fall to maintain it, because the leaf loading is the largest factor. Also a huge contributor of phosphorus to the lakes of Ontario. And then come along every 2 to 3 years and vector the sump. We've looked at the typical sediment loading rates, and we sized the sump so that it would have an over a 2-year maintenance frequency. Most separators require maintenance every 6 months to a year, where an EnviroBasin will only require the Vector truck to come out once every 2 to 3 years. As I said, 320 litres of storage in the sump of the EnviroBasin, and that is a lot of storage for roughly, say, 750 square metres or 7,500 square feet, and 40 litres of storage in the basket. The other good thing about this is there's no confined space required. Even if something goes wrong, and you can very easily maintain the system all from the road level. You don't have to climb into the EnviroBasin at all. So here's just a little video of maintaining the LittaTrap. As I said, it's very simple. It's probably the simplest of any treatment device. It takes less than a minute, and our mantra is lift, tip, and replace, and that's all it takes. And the City of Barrie can testify to this. The City of London can too. They're maintaining devices, and definitely you don't need expensive Vector trucks to manage gross pollutants. There we are. And here's maintaining the sump. You can actually maintain the system with a Vector truck if you want. And here is, this is a project in Markham actually. This is a LittaTrap, but it's the same maintenance as an EnviroBasin. And you can see in the basket here, the material is a lot coarser than the typical, what you'll find in the sump, but vectoring that out very easy. A lot of people are concerned that the vector will rip the basket, but we have engineered it to not happen like that. Of course, we just recommend a boot, and that orange piece at the end be placed on the end of the Vector truck. And then the Vector now maintains the sump. You can get good access to the sump once you remove the LittaTrap basket. And you can see here, I hope you can see how much finer the sediment in the sump is versus the sediment in the basket. And this is just, going back to how we're actually capturing different size pollutants in different parts of the device. And you can see, look how fine that material is. It's almost clay-like in the bottom of the sump. So roughly maintenance, if you form a Vector maintenance, is less than 5 minutes. Probably the biggest thing is parking the truck and putting the flashing lights out and checking the traffic is the longest process in maintaining a EnviroBasin. So big savings when it comes to maintenance. Also too, what you'll find is large separators. In the bottom of the large separator, the sediment can turn to almost concrete. And you do have to get in there and get a shovel and shovel it into the Vector truck. it can take hours to clean big separators. Where a LittaTrap, well, you have to do it more often. EnviroBasin, well, you have to do more often. It is very simple. And I mean more often in more locations. So sometimes it's a little counterintuitive. Now I'm going to run through a few little case studies using that design tool, and just show you roughly, what we can achieve, and different applications. So let's think about a highway in Etobicoke in Ontario. It's highly trafficked road. We use the rain gauge closest to that, and we space the EnviroBasins every 720 square meters. Looking at the 15-year rainfall data, we will get roughly a 59% removal of suspended solids when doing that. And here's a picture of what that might look like. So a lot of the regulations in Ontario are for 80% removal of TSS, or you must use green infrastructure or a low impact design. And this is actually really where we see the advantage of the EnviroBasin. We don't get 80% removal. We don't claim to. We claim to get 60% removal and 100% of trash. But what this means is your bioretention system downstream will work a lot better and need a lot less maintenance. Also, there is a real challenge when you're providing pre-treatment to green infrastructure or LID, is that you need to take the water from different locations. You'd have to collect these two catch basins up, pipe it over to here, where you'd have to put your oil and water separator, and then you'd need to discharge it in. Now, as Will mentioned before, we do a lot of green infrastructure in New Zealand, Stormwater 360, the parent company of EnviroPod, and we understand that with bioretention, you actually need to disperse the flow. It's actually critical for its performance. So by piping it to one place, you're going to create an area that's going to get an excessive loading at the start. And that's going to cause it to clog quicker. It's going to cause it to have lower contact times and lesser performance, then rather than having it being treated at the source and dispersed in different locations and spreading it out across the bioretention system. We actually got a number of projects in the Barrie where we're using, and also with the City of Toronto, where we're using EnviroBasin to pre-treat tree planters, or LIDs as you call them, in the footpath. And so that's a real application it's really needed, because if you put plastic bags and you put sediment into an underground tree pit system, it ain't going to work for very long. Also, the TRCA are actually looking at maybe making this mandatory for all green infrastructure systems to apply pre-treatment. Another example would be, say, a parking lot. Let's say, where did I put this one? We'll say this is somewhere out in London, but we've decided to use the SCS Design Storm. And then with a catchment area of 125 square meters, we can remove a 60% removal of suspended solids. So I'll just show you an example here of what this might look like. So box store 2. So this is your typical, big box store. Many municipalities require separators to be placed on site because downstream they have a pond. So they require on-site separators to be installed on private sites. And box store 2 was developed first. No, box store 1 was developed first, sorry. And they put conventional catch basins in. And they have a roof here, a large roof, as most of them do. And then they drain that down to the oil and grit separator. Now, you've got roof coming off. You had to, you didn't want to run a separate pipe around the side. And typically roof runoff is clean. It doesn't have a high suspended solids loading. Some municipalities don't require you to treat the roof runoff because it is clean. But it's actually a lot easier for the contractor and the engineer just to put it all into one big pipe. But what this means is your oil and grit separator will be handling much higher flows. And so you actually have to size your oil and grit separator for the roof as well as the car park, meaning it's a much bigger system. Now, box store 2 came along a year later, and actually EnviroBasin was around, and they said, we don't want to put an oil and grit separator at the bottom. We want to treat it at the source. So what they did is they used EnviroBasins instead of the catch basins. They just connected the system up exactly the same as box store 1, but they didn't need to put the oil and grit separator because the hard stand area was treated as it went into the EnviroBasin and before it was discharged into the pipe network. So the box store 2 here saved a lot of money in implementing their stormwater treatment device over box store 1. And that's really what I'm trying to make sure you guys understand, that by treating it at the source, you can actually remove a lot of redundant stormwater infrastructure, such as pipes and extra devices and extra manholes, just by being smarter and locating the treatment at the source. Another system pre-treatment option here is to infiltration. Now, this is the true heart of LID, is to reduce stormwater volumes. And plastic arches or milk crates or infiltration galleries is a very common, as the usual way we try to infiltrate these days. So they're underground structures. They have rock and a plastic structure to store water. Unfortunately, plastic bags are killers to infiltration systems as well. They're killers to turtles and they're killers to infiltration systems as well. So again, these systems can be under a big car park, multiple inlets, but by using EnviroBasin applied at the source, you would just reduce the amount of piping and infrastructure you need. If you were using a separator, you'd have to pipe everything to one location and then put it into the infiltration system. So for infiltration, it is a bit of a no-brainer to apply at source treatment. So just to summarize now, the EnviroBasin, well, it's trash and sediment capture, one of the few devices that do both. It's ETV verified, so you can specify it with confidence that it will meet the standards. It meets the oil and grit separator standard for solids removal. Hydraulic effect. Its maintenance, while different, is very simple and less cost than a conventional oil and grit separator. It's, as I said, less stormwater infrastructure, less stormwater infrastructure. It's really ideal for pre-treatment for low impact design. And as we move forward in our stormwater management effort, we really need to manage this. But low impact structures can only do this if they're kept free of trash and sediment. And lastly, the system actually was developed and tested in Canada by a bunch of New Zealanders that moved over to you guys. But we worked with Canadian authorities to develop the system for you guys. So that's me. Well, hand it back over to you.
Mike, that was fabulous. And I noticed we're at the top of the hour, so you finished exactly on time. That was a great presentation.